What is simulation? Also known as the finite element method, the finite element method, FEM, is a numerical technique for finding approximate solutions to boundary value problems for partial differential equations. Let's try that again. Simulation. To bring your existing CAD model, or a simplified version of it, into a virtual test environment in order to predict performance. That's better. Simulation is a key part of manufacturing today, but it will be absolutely essential in the near future. We at M2 partner with Autodesk because Autodesk is looking forward, beyond the needs of industry today. We aim to prepare our customers to thrive in what Autodesk is calling the future of making things. I won't go too deep into this concept today. Here's the basics. Many manufacturing organizations today adhere to a standard linear product development process. This process is broken up into 5 primary phases: the concept phase, design, production, sales and marketing, and finally operation and retirement. Mass production of a few key designs is the name of the game. This process is like an ocean liner. Once it's moving, it's hard to stop, and it doesn't turn on a dime. This leads to a product of fixed value that is never more than the sum of your input costs plus your profit. It's hard for any one producer to differentiate in the marketplace. It's difficult to stay in tune with a rapidly changing marketplace. Your product may be obsolete by the time it makes it through this cumbersome production process. This is all changing. In response to a marketplace that increasingly demands customized and personalized products, forward-looking companies are beginning to move away from mass production and into mass customization. The most successful companies are utilizing the now mature communications infrastructure and collaboration tools to communicate with experts around the world. No longer are organizations restricted to the talent and expertise in their local area. The manufacturing processes themselves are evolving into more nimble processes, able to change as rapidly as the marketplace does. Customers today expect information and services along with their products. The Internet of Things will benefit customers and producers alike. Customers will be able to communicate with their products and get the experience and service they expect. Products will communicate with producers, providing valuable performance feedback into the concept phase of the next production iteration. And producers will be able to communicate with their products, updating them with new features. The product will begin to resemble a service. This means that the product can actually increase in value over its lifetime. No longer is the process static and linear, but it's truly an agile product life cycle. This is the future of making things. Autodesk's answer to the challenges we will face in the future of making things is the Product Innovation Platform. Autodesk is in a unique position to help you, our customers. There are many CAD, CAM, and simulation software providers out there. However, Autodesk has solutions for every aspect of the design process, from CAD to CAM to CAE, IoT, and PLM. A single partner can help you with all of your acronyms. Upfront simulation takes place in the design phase. The design phase is where we find opportunities to improve product performance, win more bids, increase innovation, and reduce warranty issues. Why simulate? Simulation leads to better products in less time and at lower costs. It provides a preview of performance of the design. Costs can be reduced as fewer physical prototypes are needed for testing. Reducing the time needed to test the prototypes also reduces the time to market. Requests for quotes can be returned quickly and with more confidence that your design will perform. Win more business. Let's compare the traditional design process with the design processes we see in the future. In the traditional design process, the initial concept is developed using a combination of past experience, hand calculations, and educated guesses. Using this method, it is not unusual for the first physical prototype of that design to fail. This results in the need for another iteration of the process, which means more design time and another physical prototype to build. Each iteration of this loop adds cost to the process and increases the time it takes to get to manufacturing and to market. When a design does pass physical testing, there is little confidence that the design is optimized. It did not fail, but is it over-designed? In contrast, the Product Innovation Platform uses simulation, or virtual testing, to eliminate failed designs before a physical prototype is constructed. Initial concepts may fail to meet requirements, but iterating digitally is far less time-consuming and costly than iterating physically. In fact, iterating the design is so efficient with simulation that the designer can afford to continue iterating even when the design is passed, in the search for a design that not only works, but is of the highest quality and lowest cost. New innovations can take shape, and better products are the result. All of this before the first physical prototype is constructed. Defects that may lead to unsatisfied customers can be uncovered while corrective action is still relatively inexpensive. Materials and design features can be optimized, leading to a higher quality product. Finally, innovation is fostered. There's less risk in exploring a radical design change when you're using a digital prototype. That crazy idea could be your next big innovation. So when is the best time to simulate and optimize your design? Over the product development lifecycle, the ability to affect the functional capabilities of the design declines as the cost of making changes increases. The best time to identify failure modes is during the design and engineering phase. This way, the design is still flexible enough to make the necessary changes, and costs of those changes is minimalized. What makes Autodesk simulation different? Who uses Autodesk simulation? The names you see on screen are makers of some good simulation tools. In fact, they are great simulation tools. We at M2 and Autodesk don't see ourselves in direct competition with these products. In many instances, Autodesk products live in harmony with these products within the same company, because they serve different purposes. Let me explain. Note the triangle graphic on screen. This triangle represents the entire community of engineers and designers. Traditionally, highly educated and highly specialized individuals, represented by the top portion of the triangle, have been relied upon to perform FEA analysis. These individuals are typically career analysts. They are expensive people who use expensive tools. This type of analysis is often done at the end of the design cycle for validation purposes. Autodesk simulation is part of a newer approach to simulation, called upfront simulation. It's for the everyday engineer and designer. These individuals often wear many hats, and running analysis software may only be a part-time role. They need results early in the design process to help them make more informed decisions while the product is still in development. For this reason, they need the tool to be easy to learn and easy to use. Autodesk simulation serves these users.